The oldest running diesel engine in the world is a remarkable piece of industrial history, preserved and demonstrated at the Hochschule Ostwestfalen Lippe in Lemgo, Germany. This machine, a MAN 12 German Marks built in 1903, is considered a milestone in engine development and still operates more than a century later. With a power output of 12 horsepower at 250 revolutions per minute, it reflects the modest yet reliable performance of early internal combustion technology. Its single cylinder, with a displacement of 10 liters, showcases the massive proportions that were once necessary to generate power in the early days of diesel engines. Manufactured by MAN in Augsburg, this engine demonstrates the engineering vision of Rudolf Diesel's pioneering concept brought into practical use. For several decades, it has been maintained by the Department of Mechanical Engineering at the Hochschule. Each year, it is run during the university's open day, allowing visitors to witness a living artifact of mechanical innovation. Despite its relatively low efficiency compared to modern standards, the MAN 12 German Marks remains a symbol of progress and durability. Its survival and continued operation make it not just a machine but a cultural treasure that connects the past of engineering with the present. The three-cylinder Fairbanks Morse diesel generator engine is a remarkable piece of American industrial history. Built in 1948, this engine represents the durability and engineering excellence of its era. It is a two-stroke diesel with 3 cylinders, designed specifically for use as a generator engine. For many decades, it served as the main source of power for the town of Eureka, Nevada, providing reliable electricity to the community when modern grid connections were not yet available. This engine was more than just a machine. It was the backbone of local life, ensuring that homes, businesses, and public services had the energy they needed to function. Its continuous duty and robust design are clear demonstrations of the Fairbanks Morse reputation for building engines capable of handling tough operating conditions. Even after mainline power was eventually brought into Eureka, the engine was not retired immediately. Instead, it was kept on standby duty for another 10 years, ready to be called into service in case of emergency. This extended period of reliability highlights its importance and durability. Today, the engine stands as a historic example of mid-20th century power generation, reminding us of the role such machines played in the growth of American communities. The Snow 600 horsepower gas engine at the Cool Spring Power Museum is a massive machine built in 1917 by Snow Holly Works of Buffalo, New York. It features two tandem double-acting cylinders, each with a 24-inch bore and 48-inch stroke, delivering 600 horsepower at 100 RPM with an incredible torque of 500 foot-pounds. Measuring 75 feet long and weighing about 140 tons, it remains one of the largest preserved running gas engines. The 90 horsepower National Transit Klein Model B two-cylinder gas engine represents a rare and important survivor from the early age of large stationary engines. Built to deliver reliable mechanical power for industrial applications, this engine is one of only a couple of known examples of the two-cylinder Klein still in existence today. Its preservation and continued operation provide a unique opportunity to appreciate both the engineering skill and industrial heritage of the late 19th and early 20th centuries. This particular machine is rated at 90 horsepower, making it a powerful workhorse for its time. The two massive cylinders are the heart of the engine, designed to run on gas and deliver smooth, continuous output for extended periods. Like many large engines of its era, the Klein Model B was engineered with durability and simplicity in mind, ensuring that it could operate in demanding environments with minimal interruption. What makes this example especially notable is its extensive restoration. After years of careful work, including dismantling, cleaning, machining, and replacing worn parts, the engine was finally brought back to life. The restoration process took multiple years and required the dedication of skilled enthusiasts determined to preserve its historic value. The first public run following this restoration was a milestone moment. Once started, the engine required some fine-tuning and a little heat in the cylinders to reach optimal performance. When it settled into its rhythm, it ran beautifully, demonstrating the remarkable design and craftsmanship of National Transit. Today, this twin Klein engine not only stands as a mechanical exhibit, but also as a living, working piece of history. Its rare survival, combined with the dedication to its restoration, ensures that future generations can witness the power, sound, and motion of an authentic industrial giant. The 90 horsepower twin Klein engine was recently operated publicly for the very first time after an extensive restoration lasting many years. This historic machine, once silent, came back to life with impressive performance. Before starting, the engine required careful adjustments and slight warming of one cylinder to ensure smooth operation. Once these steps were completed, it ran steadily and powerfully, demonstrating the success of the restoration efforts. The engine's strong and reliable motion not only highlighted its original engineering excellence, but also celebrated the dedication of those who restored it, allowing modern audiences to witness a remarkable piece of industrial heritage in action. The massive vertical 40 HP Cephal hot bulb engine is a remarkable example of early 20th century internal combustion technology. Built by a Scandinavian manufacturer, it relied on a heated cast iron bulb for fuel vaporization and ignition rather than diesel-style compression. Capable of burning heavy oil, it was well suited for industrial and marine applications. Although less efficient than later engines, its size and power made it invaluable in its era. The Witte Diesel 6 HPKD diesel-electric is a classic example of a small stationary diesel engine designed for rural power generation. Built by Witte, a company founded by August Witte in Kansas City, Missouri, this single-cylinder engine delivers 6 horsepower and was commonly paired with generator sets for farms and small businesses before widespread electrification. Its KD designation identifies it within the Witte lineup. Operating on compression ignition, the engine eliminates glow plugs or hot tubes, relying solely on the heat of compressed air to ignite fuel. The Papendrecht Historical Combustion Engine Foundation preserves unique technical heritage in the Netherlands, focusing on stationary and marine diesel engines from 1905 onward. Its collection includes around 30 working engines, carefully maintained by passionate volunteers, and features rare pieces alongside a modern training center and exhibition space for enthusiasts. The Nordberg radial engine, first introduced in 1947, was a groundbreaking design offering major advantages over conventional inline engines. With horizontally arranged cylinders and a vertical output shaft, it was compact, lightweight, and required only half the space and foundation strength of comparable inline models. Initially built as spark ignition natural gas units for aluminum reduction, the engines proved highly reliable and economical. Their configuration also made them ideal for pumping applications, including flood control and sewage treatment. Nordberg later developed diesel and dual-fuel versions, the latter capable of running on flexible diesel-natural gas mixtures for greater efficiency and cost savings. The Tangye MLD-7 diesel engine represents an impressive milestone in the development of large stationary power units in the early 20th century. Manufactured in 1929 by Tangye's, a well-established engineering company in Birmingham, England, this machine showcases the robust design and engineering precision that characterized the period. It is a horizontal twin-cylinder, four-stroke diesel engine, specifically designed to deliver reliable power for industrial applications. With a rated output of 168 horsepower, it was more than capable of meeting the heavy energy demands of factories at the time. One of the most distinctive features of the MLD-7 is its large cylinder bore of 16 inches, which enabled it to generate substantial power while maintaining steady operation. As a horizontally configured engine, it achieved both mechanical stability and efficiency, reducing vibration and wear compared to vertical designs. The particular engine preserved today originally served at the Witte cider factory in Witte, England. There, it played a vital role in powering the production processes, ensuring a consistent and dependable energy source before the widespread adoption of modern electric power systems. Its service life illustrates how critical such engines were to Britain's industrial growth during the interwar years. Today, the Tangye MLD-7 holds a place of honor at the Internal Fire Museum of Power, where it is carefully maintained and exhibited. As one of the few surviving examples of its kind, it not only highlights the technical achievements of Tangye's, but also provides visitors with a tangible connection to the industrial heritage of the early diesel era. More than just a machine, it stands as a reminder of the ingenuity and engineering strength that powered entire industries nearly a century ago.